Hi, everybody, and welcome to Build Meets World, our broadcast where we get out in the field and have guest contributors. So today I'm really excited to talk about testing, both lab and field testing, with my friend JP McDonald. So JP, welcome to the broadcast today.
Hi, how you doing?
So tell us about yourself, your experience, and of course, the building enclosure consultants and scientists that you work for.
Sure. So my name is JP McDonald. I've been, really, when people say they're in the industry, I've really been in this industry for over 18 years, and kind of started at a place called the Hurricane Test Lab in West Palm Beach, Florida, and just have been, kind of moving across the East Coast. And currently I'm with BCS, a partner at BCS, and we've opened up a test lab called BCS Labs outside of Raleigh, and yeah, so our BCS is is really what I call a designer of record firm, and which means we do big repair jobs, and on the other side of things, we do new construction consulting, and we do our field testing and lab testing as well. So kind of a full gambit scope of services, which they kind of vertically integrate and kind of cross-reference each other very well. So.
And and it's interesting you mentioned the Hurricane Test Lab down in West Palm Beach. So obviously, we're sending out we hope everyone's okay, staying safe with the Hurricane Ian, excuse me, that's going through Florida right now. So we hope everyone's staying safe no matter where you're at.
Yeah,
but once again,
sorry about that. Yeah, we have Jack, we have an office in Jacksonville, Florida, and he's kind of hunkered down right now. So.
I wondered about that. Yeah, so I'm sure you're checking in with your colleagues and your friends as well.
Yeah. So did you just want to kind of go through these and
yeah,
have at it?
I think it would be great. I'm loving this picture right now.
Oh yeah, so just I mentioned what we do. So we're envelope consultants. We could be owner's rep. Again, we're an AMA accredited third-party test lab, and do design of record work, and we do envelope commissioning agents. And one of the things we're very proud of, about 60% of all our staff hang on ropes, on the side of buildings, and we've really kind of integrated. That's more to do building assessments and whatnot, really hard to reach areas, of course. And we've kind of intertwined that into our field testing, which you'll see some photos, which I think is really industry leading, where we'll hang off of a large high rise to do some nozzle testing and whatnot, or some smoke testing on ropes and stuff, which is pretty unique, so. So let's just kick off, so what's the difference between, kind of lab testing and field testing? They're actually very, very similar, so I'm just kind of go through this. So the picture on the right there is a typical, and we're talking more, I guess in this conversation, is more fenestrations and doors and whatnot, but it's very closely tied to air barriers and cladding and everything. They're all kind of the same test, So on the right there, there's a typical Lexane wall. There's what looks like there's a patio door in there. It actually got hit by a hurricane, impact missile there. It's being cycled. But basically, that test wall can do certain tests, and let me back up a little bit. So the building code, why do we do testing? So the building code references the model codes, ICC codes, references kind of like consumer reports for, VCRs or toys or whatever. For you to come out with a product in the United States, the code defines what you need to do. And so kind of the basics of that for fenestration products are operation force, so that, people that might not have all the muscles in the world can lift up a sash on a window, air infiltration for reasons of comfort and for thermal performance, water performance for obvious reasons, you don't want water to come into your building, structural performance, and thermal performance, and some ancillary things like acoustics that aren't necessarily required by code. And if you're in a hurricane region, hurricane resistance, and then if you're coming out with products that might be resistant to tornadoes, there's tornado codes and whatnot, And so I listed some test methods here that kind of the basics. And one of the test methods listed here is AMA 501, which is actually referenced in Florida, in the Florida Building Code, which is a twin span mock-up and kind of, that has the same exact test methods, air, water, structural, kind of the basis for that, but it's in a 2-story kind of full scale mock-up, and I'll go over that in some later slides here.
Yeah, so that's interesting. So obviously there's going to be elements of your building enclosure that you need to validate, and then how it all comes together as a system, right? So a lot of that is, it obviously is important to understand the differences between the two.
Yeah. So then what's field testing? So I have kind of the basics of field testing is quality control typically for a new construction project, and typically it's not required. We got maybe one state reference to requiring field testing in the country, but besides that, it's really all just quality control for new construction, because the developers and even general contractors and architects want to mitigate their risk for rework, because they don't want their buildings to leak, basically. But the essence behind this is that the tests that are done in the field are the exact same tests that are done in the lab. There's some nuances to that, but in essence, that's what it is. And the reason for that is because we can't test things in the field that the manufacturers tested different when they came out with their products. Because if they failed, or if we think that certain products pass, then we don't know if they're performing properly. So I'm going to go through that. One thing to mention is that what's the difference I have on this slide? I have AMA 502 and 503. What's the difference between ASTM and AMA? So AMA is an association of manufacturers and consultants and whatnot. It's just an association, and they've come out with specifications which include air infiltration and water penetration, where ASTM is really the test method of how you perform the test. And so specifications really define what pressures to test to, what the pass-fail criteria is, where the ASTMs don't necessarily do that. So really they're used in the industry kind of interchangeably, but that's just kind of a nuance that not a lot of folks know.
Yeah, thanks for pointing that out. It's a great, it's definitely something that needs to be explained, because the test method doesn't give you a criteria, where your specification is going to give you that criteria. So if somebody just lists a test method, what are they testing to, and what's considered good results? That's difficult.
Yeah, we could just talk about that for 30 minutes, if we wanted to.
Yes, we could.
But in essence, there's a default, so AMA will have a default, say, this is what we suggest that in the field, this is what we suggest you test to. And then there's always a, kind of a loophole, or maybe it's a high performance building and the architect really is trying to strive for high performance, and they might have performances above and beyond that, and they can do that if there's no, there's no laws, but there's defaults, and there's kind of above and beyond that as well. So I'm just going to kind of go through some of the specifics of lab testing and field testing. So here's a slide that's a water test in the lab. So basically we have, what's a water test? So typically it's depending on if it's a residential window or a commercial curtain wall or a skylight. Typically the water tests are between 15 minutes and 24 minutes, depending on what the product is. While you're spraying water, there's a simultaneous pressure differential which simulates wind load. And that wind load, that pressure is typically 15 to 20% of that structural design pressure. And I'll kind of go over that a little later. But in this photo here, you see a window that's clamped to a clear wall. That's because in between that window and that wall, there's a pressure differential, and that's there's a vacuum on the back of that, and it's sucking air, and that's simulating the wind load. We have this hurricane. Is it Ian? Hurricane, I think it's Ian that's coming by.
Yeah.
I've been through a few hurricanes, and you can really see, the fluctuations in air pressure, when a hurricane's going by. And so it really is going to realize that pressure differential inside the building, and that's really what this is simulating. So really that water it's just a fun fact is 8 inches of rain in 15 minutes. You know, so people are talking about in Florida right now, we're going to get 24 inches of rain, you know, and really
Yep.
8 inches of rain is a ton in 15 minutes, you know, but it's just a standardized method so manufacturers can have kind of a baseline or, you know, to kind of figure out how their products are going to perform. So really kind of the next bread and butter test at the lab is air infiltration. And I have a whole bunch of numbers on the screen, so sorry, but really I'm trying to just compare. You know, really this is either infiltration or exfiltration. In the United States, we're really concerned about infiltration. In Canada, there's some exfiltration criteria. But if you have a residential window, you're around 0.3 cubic feet per minute per square foot of that product. So air flowing through that product, that's kind of the code minimum, you know, so you have to be less than that to have your product be sold in the United States. And that's typical for residential products. There's some nuances there. And then we get into commercial products like aluminum windows or whatnot on you know, in hotels and whatnot, or curtain wall and storefront. And then you get down to 0.6 and 0.1 CFM per square foot. And then in air barriers, you can get all the way down to 0.04 CFM per square foot. And then we jump up to entrance doors, say side hinge doors or whatnot. You jump way up to a whole one CFM per square foot. And where does this kind of come from? The code also defines that your entire building, the air barrier, the windows, the doors, everything, the roof to wall connection, everything should be in an entirety should be less than 0.4 CFM per square foot. And that's kind of a, you know, there are some other specifications, you know, passive house or federal buildings and whatnot that can go all the way down to 0.1 CFM per square foot if you have, and typically those are super high performance buildings or net zero performance buildings of that nature.
You know, and I like how you put this together, because I love how it explains that, you know, the elements of your building have requirements, and they have requirements because when you put them all together in an entire building, your goal is to have, you know, as close to an airtight structure as you can get. And if you're testing to this requirement, you're going to want to make sure that all the pieces and parts that are going in aren't going to contribute in a bad way, you know, to your air leakage on the end. So.
Yeah, and this is going to make sense when we go into the field slides. And here's just a structural. It's important because pretty much all those other tests are kind of based on the design performance, and that, you know, the defined roots of structural performance is in the ASCE 7, which is the manual for structures and designing structures in the building code. And so how we do that, you know, it can be engineered, you know, by an engineer to do, you know, basically just using computer software, but everything pretty much needs to be physically tested, just because the nuances and the connections in windows and even walls and whatnot are you can try to engineer them, but you really, there's so many nuances that the code says you have to test this just to make sure, you know. And so testing is kind of that same air pressure we use during a water test and during an air test, where it's just much higher. And typically the loading for that is between 10 seconds all the way up to 60 seconds, you know, and some skylights and whatnot to do that. And that's in different regions of the country, depending on what you're doing. And testing does involve the safety factor, you know, so you have design loads and certain criteria for that. And you have the safety factor, which is you know, a certain multiple above and beyond what you're designing that structure for. And sometimes that's 1.5 times, sometimes that's 2 times. And typically at that safety factor, there's you know, some common sense criteria where there can't be any permanent damage to the window and whatnot, or any significant permanent deformation or glass breakage, you know. So then we get into, you know, the reference before AMA 501, you know, so what is that? You know, a lot of people in the industry are, as soon as they hear 501, they think 501.2, you know. So 501 is not 501.2. You know, so 501 is called out in Florida. You know, and it's really a twin span, 2-story mock-up where that association we mentioned before, FGIA AMA, came up with this methods of test. It's really a gambit, a protocol, a gambit of testing that includes what I have listed here, air, water, structural, but it kind of goes the extra mile. It really wants to figure out if in a 2-story condition, there's lots of thermal expansion and contraction, and really wants to figure out that the whole system, when you get to multiple stories, everything works together, and so you could have, simple mock-ups and very complex mock-ups, and I don't like to talk about price, but these could range from $10,000 to $500,000 mock-ups, very intense mock-ups, and typically these are done for high rises, custom curtain wall systems, but they can be done just to kind of solve kind of transitions between brick and metal panel and glass and whatnot. And typically it's the tests are listed here, but it's the main component is this interstory displacement and thermal cycling to see if you have the same air and water performance before and after interstory displacement, or before and after thermal cycling.
And I love that, because it's demonstrating the effect of the testing on your system, right? You get a baseline, you put it through the thermal cycling or interstory displacement, test it again, right, for air and water. So is there anything different? And the valuable lessons we're learning from that are huge, right? To then put that in your mind as you go to the building, where this is going to happen over and over and over again on the entire structure.
Right.
So.
And other criteria that are kind of unique or special for a project that could be acoustics, where you could have padded walls, and you're measuring a decibel level, dampening and padded walls, or condensation evaluation to make sure we don't have any condensation, or if it's in a hurricane region, you could have hurricane resistance or human impact in a psychiatric facility, or fall protection from things falling within New York City. So all those can kind of be integrated into a performance mock-up. So then we'll talk about mock-ups. Everyone's very used to aesthetic mock-ups. We call them parking lot mock-ups or standalone mock-ups, really just to see if, the owner of the architect likes finishes, on the outside of the building, and more and more common, they're converting these aesthetic mock-ups into performance mock-ups on site, which are, like you mentioned before, are super valuable, and really solving constructability problems, sequencing problems. If there is a problem with air infiltration or water penetration, you can include all the assemblies to really get a good idea of, if you do have a whole building air test at the end of your job, what's the, what's the air leakage of the whole building, kind of in a smaller scale and whatnot. And some tests we can do in the field, and some tests we can do in the lab. It's really hard to do an acoustic test in the field, or it's hard to do a condensation evaluation in the field. So really, these are limited to kind of air and water tests typically in the field. So then we're talking more.
And I think you mentioned it already, but that's why we tend to do in the lab, when we do things in the lab, we do them to more of an extreme situation, like that 8 inches of water, right? Or the 1.5 to 2 times the safety factor, because we're trying to do everything we can in a lab to a higher level, knowing that we can't cover everything that you would see in the field. So we're going way above and beyond, right? To get that understanding. Yeah.
So back in the previous slide where we mentioned AMA 501, that there's a gambit of different test methods, 501.1, 0.2, 0.3, 0.5, 0.7, and so on. 501.1 is both done in the lab and the field, and typically it's like an airboat engine or some sort of portable machine that could be down here on the right. This is ours, and this was a recent project a couple weeks ago at UNC Surgical Tower. That we did, and really you're creating the wind while you're spraying water, and so it's a fantastic test to kind of go through that, and it's still associated with that 15 to 20% of the structural capacity of how that product is defined, and so and I get this question all the time, what's worse? We're going to go over ASTM E1105. And this test. So what's worse, a chamber test, as it's known, or a static water test, or dynamic water test. And really, they're supposed to be, in theory, they're supposed to be the exact same. And I asked a PhD guy that a couple months ago, again, and I kind of, have this gut feeling that, that the, creating the wind is a more real life scenario, real life condition, and that the static water test might be a little more stringent, but Mr. PhD says they're supposed to be the same. So, but typically just in the field, this is like it could be a 10 by 10, spray rack or whatnot, and so you can kind of knock out, a bunch of these in a single day. It's attached to a lull or a telehandler and whatnot.
So the ease of this one, it's pretty easy, right? Because like you said, you can handle a 10 by 10 area. You're just putting the equipment in that direction. And
it's gas powered. There's nothing on the inside. You just strap it down to make sure everything's secure around you, because people don't think 60 miles an hour wind is a lot. It's a lot. It's really a lot of wind. So you need to be safe when you're doing it and whatnot, So then back to the famous 501.2, it's really what we call a handheld water nozzle test. In my opinion, this is really used for forensics. It's commonly used, for a glazing contractor, because it's quick and easy. The equipment's easy. It's just a hose and a nozzle to go over the lineals of a commercial product, and to check their work before maybe they don't have a third-party testing agency, because the project doesn't have the funds to hire someone like myself or another company to come out, and so the glazing contractor does this by themselves, and so it's good in that area. The problem is that it's not in that gambit of testing by a manufacturer. I'm sure the manufacturers test it anyways, but when you have a submittal for a commercial product, this is not typically listed on those products, so you can kind of get that nuances, but it's used all the time.
Well, and I like how you suggested, a lot of times they do that. Our glazers want to verify their installations, right? So they'll pick an area and they'll be able to go back and just see how things are going. If there's a questionable spot or area or installation concern they have, they can go ahead and do this.
Yeah, and a lot of these can be run incorrectly, too. So I have, I don't like reading off of PowerPoints, but this is supposed to be a foot away. It's supposed to be perpendicular. You're supposed to always be moving at one foot per minute, kind of rate, and back and forth. So if you're 3 inches from the curtain wall, and you're really pounding it in at an angle, then you could make something leak, and that's always something to think about. All these water tests, if you're doing it incorrectly, you can always make something leak, which could be a big problem on a construction site. Where you're really you're thinking back to that lab testing, where you're really trying to make sure you're doing everything the same that you did in the lab, so that you're trying to figure out if the performance is still there.
Yeah.
So here's just a cool photo of us on ropes. It is easy to kind of access and kind of get to hard to reach places there. So then we get to kind of the other more common test that's done in the field, ASTM E1105. And I mentioned before, AMA 502 and 503. E1105 is inside of those specifications. And basically, this is the exact same test as that ASTM E331 and E547. Basically, it's a spray rack on the outside with a chamber on the inside with a pressure differential simulating wind load. And these are a little more complicated compared to that wind generating test, because you have to build a chamber on the inside. I think I have some photos here. So here's kind of a smaller residential setup, and here's just a small chamber on the back side of the wall that you in your equipment here. And here's just another situation where you're basically pulling a pressure differential at a certain pressure. There are some nuances where people always talk about a reduction. AMA calls out as a default as a reduction in test pressure, and that's not the water pressure, that's the air pressure that's going through the system while you're doing this test. And it's a 1/3 reduction of typically what's done in the lab. That's kind of the rule of thumb. And again, a project specification can either allow that or not allow that. in my opinion, it's we're an accredited lab. I think it's a great thing to do because, really in a lab, all conditions are perfect. You have your best crews and the whole company come out and do these mock-ups, and they're perfectly level, perfectly plumb, perfectly square. And you could try a few times to get it to pass, and then it finally passes. You're great. Write the test report. Where in the field, especially if you have mold assemblies, from the factory, and they go in a big truck, and they get wrapped and whatnot. They're not going to have the same performance as they had when they tested in the lab. So that's really why there's a reduction there, and there's kind of a big debate in the industry about that. But that's kind of what that is. Here's just a cool. Typically, when you have a big commercial project, you just test very critical areas. Then we kind of have this sloped inside corner here where we have some critical three-way conditions here and down here, and some areas can be really hard to access, and you can really build chambers that really accommodate anything, and typically use a clear plastic with some framing to pull that off. But you can also do walk-in chambers. So this is on a construction site. It's a 2-story chamber, so really there's another chamber on the floor below, and they're connected, and you can witness the test inside, so you're not looking through plastic. And it's just another option, to kind of get more hands-on there.
And I love how this really demonstrates the versatility of this test, because I think a lot of times, it's people think there's it can't be done on a high rise, or it can't be done, like you showed with it being able to walk in. So I love that you're sharing that versatility of this test, that it can be done, in those different conditions.
Yeah, and really, so one thing to bring up is all these test methods here. It's kind of the title, from the test method here. It always says windows and doors,
Yeah.
But really, this is done on cladding, on metal insulated panels, on air barriers, on transitions and whatnot, and really when you kind of go back to the building code, there's kind of exceptions to the rule for building performance, and where water's supposed to be kind of flashed and drained out, and with a wind load, and really it's a 4-hour test with with wind pressure, so really all systems are supposed to perform with some sort of wind load with this spray rack of water, everything essentially, and so even though the standard says windows and doors, it's really applies to pretty much everything on the outside of the building.
Yeah, the building enclosure connections or the wall. Yeah.
Right. So back to the air infiltration in the lab. The exact same test is done in the field. Again, there's some nuances of criteria that are a little more, less stringent in the field, but essentially, you're pulling a pressure and measuring airflow, and you utilize what's called a tear bag, which is just plastic sheeting, to kind of make sure that you're only measuring airflow through what you want to know, which is only, this is kind of different than the water test. The air infiltration criteria is really just for the products. So if you have high airflow between the wall to window connection or something, for some reason you might have, I've been in situations where you have weep holes in the wall system, below the window, and really the air criteria, that's kind of above and beyond, a window, so when you're doing this, you're really comparing this to the window performance in the test lab, and whatnot, so, and I have a picture here, and some people listening to this are probably like, oh, that tear bag's over these operable windows, that's bad, and so you're really, the air infiltration criteria for an operable window may possibly be different than the fixed section of that mold assembly, so you would really want to obtain air numbers for both the fixed window and the operable window to make sure they're both okay, and then the whole assembly. So.
And you mentioned at the bottom there, it's typically combined with 1105. Do you get where somebody just wants to understand the air infiltration?
It's very rare, sometimes, yeah, so as you see in the picture on the left here, this is your typical chamber there. And so we have a kind of a device that's generating the airflow, so a blower that's sucking air, and then a airflow meter that's measuring airflow. And so this is the same exact chamber that was utilized for that water test.
Right.
So that's why
it makes sense
typically done
to
at the
then
same
do
time.
the water test for that reason too. Yeah.
Yeah. So, we can talk about air filtration. I think we talked yesterday. I can talk about air filtration for a long time. So there's certain situations in the field where you can have kind of a false positive result when doing air testing, and that's typically when you have ribbon windows or continuous curtain wall or storefront windows that are continuous, and you can't, compartmentalize is kind of the word in the industry, compartmentalize what you're testing. So if it's not a punched opening, then typically, if it's something that's continuous, not a punched opening, typically you shouldn't do E783, because the result will come out fantastic. It'll say you don't have any air leakage, when in fact you might possibly have it. And so in those scenarios, you should really do a smoke test. So basically, we're using the same chamber, same pressure differential, and we're kind of visually looking for air leakage. And there's a lot of, kind of debate, not debate, but some question. If you do get some smoke in, there is an allowable amount of air leakage. So you really have to discern, how much smoke is too much. If it's a small amount of smoke, that might be okay. If it's a large amount of smoke, then it's a cause for concern. But it's tough. I've been in situations where I've had a lot of smoke, and I kind of raised the red flag, and everyone else said it was okay. So it's kind of,
I bet that makes it.
I'm like, okay, because if you have too much air, you might have condensation,
Right.
And that's really the main. You have discomfort. Of course you'll have, air infiltration is convection, so then that's lack of thermal efficiency through convection, but also you'll have condensation, which is, obviously causes problem like, corrosion and whatnot in walls and on different things, and mold and whatnot, so air filtration is pretty important. And then we mentioned before the whole building air test, which all kind of comes together. And this test method is wrong. Sorry about that. It's E799. It just must have been that's a mistake right there. So that's an anchor test. But anyways, so this is where you're measuring airflow through everything, and kind of getting that air number, as it relates to air testing, so.
And with the whole building air testing, it depends. You can do it at different stages throughout construction, right? You don't have to do it when it's done, or is there a certain? Do you want to do it a couple different times? How would you recommend?
Yeah, so just, I mentioned the mock-up before, like a standalone mock-up. If you can build a chamber that incorporates, first of all, if your mock-up incorporates slab conditions, inside pouring conditions, outside pouring conditions, and also incorporates the wall to roof conditions, if you include all that, and if you build a chamber to encapsulate all of that, not just test, a lot of people, they build these mock-ups for aesthetic reasons, or they might think they're building it for performance reasons, and then they'll only test the window, and really that's a big miss on, for the project. You should really, test everything and get a good picture on everything, and if you do that, you can get a great idea of air performance in the whole building. And then, if you're doing spot air checks on the air barrier, spot air checks on the windows, and maybe some smoke testing as the project's going on roof to wall conditions, or weird transitions of opaque wall conditions, penetrations and awnings and whatnot. And if you go through all that, then you're well prepared for your whole building air test.
Yeah, you should feel pretty good going into this then, if you've done all that.
Because if your project has a requirement, you have to meet a certain level. If it's a military job or something like that, then or if you're going for, passive house or something, then you really want to kind of do those things up front. But a whole building air test, you have to have 100% closed envelope. So your doors are supposed to be in with your sweeps and your doors, which is a big thing. Every whole building air test, they never have the sweeps on the doors, and everything's supposed to be kind of buttoned up there, to do that. So, and then here's this probably could have been early, but just another air spot leak check on air barriers and whatnot. Just kind of look for air leaks there, part of the quality control system. And this is just we use this when we do adaptive reuse or whatnot, and on some of these old mill buildings, that need to be repointed, and we kind of can do a before and after. But it's just kind of a good point to make that there's a whole bunch of other tests that we haven't talked about that can be kind of quality control tests, like infrared electronic leak detection and whatnot. We're really just kind of talking about fenestrations in this presentation. For example, this is a water test, but it has nothing to do with typically, to do with water leaks. It's to measure the absorption rate in the brick, to see if it's kind of acceptable or not, and if it's too high, of course it might have cause water leaks, or it might cause condensation problems behind the brick if there's plaster or whatnot, and cause some real serious problems. So there's just different tests out there that you can do that kind of aren't kind of the basic tests that we talked about. So.
Yeah, no, and I like that you shared that, because it does really help us kind of conclude what we're talking about today. One, you talked about a lot of different tests, and we could have talked probably about each one for an hour or more, right? And there is a lot of other test methods that might be more representative to whatever it is that you're looking at out there, right? So what we tried to handle today was more of a broad look at some of those lab tests versus field tests, and how do they compare. I love your explanation once again of how we got to that whole building air tightness test, right? So if that's your end game, let's look at what those steps that we need to get there and get there successfully, right? And it has to do with material selection, system selection, and performance along the way. So
I think that
super helpful.
Yeah, this is kind of a 101 for lab and education for lab and field. I think that the main thing to take away is products are tested, kind of consumer reports in the lab, and they use certain test methods, and really the quality control testing in the field, it's really the exact same test methods, and you really should, you really need to test them the same in the lab, because you could make things fail, or you could have, or you might not be testing them up to the performance that you should, and then you might have leaks later on, because maybe you're not spraying enough water, and then all of a sudden a heavy rainstorm comes by, and you're like, oh, my building's leaking, it's only 2 years old, and maybe it wasn't tested up to the performance that it should have, so yeah.
Lots of specifics we could get into depending on use of building, location of building, materials added up to the building, how many stories the building is, right? There's so many more things that we certainly could talk about. Thank you so much for sharing all this information with us today. Do you have any final words for us before we say goodbye?
No, not really. That was fun, and yeah, just if you have any questions, you can always reach out to me, or I'm sure Marcy. Reach out to Marcy, and yeah, that was fun.
Yeah, definitely. I'm sure this is bringing about some questions for you. So just as JP mentioned, if you have any questions, you can go ahead and just reach out directly to me if you don't have JP's email, but we will definitely get those questions brought to JP for that. The ability to answer those questions, because I'm sure there is some that we'll need to answer after this, but lots of great information. Thank you so much once again for sharing that with us today, and hope everyone has a good rest of their day.
All right, see you later.